All right, hi, sixth grade teachers. After spending some time in some classroom recently, I have definitely been seeing us be working in our sixth grade classrooms on, some basic pre-algebra stuff. And a few teachers have brought to my attention that, students are struggling, especially like our ELL students are really struggling grasping onto these concepts. Algebra tiles can be super helpful here. So I went ahead and created like a lesson that can be used in small groups. It can be used for direct instruction. It can be used for review. And it will basically take us through 5 separate parts. The first part is just going to be about, the vocabulary of an algebraic expression. And so you can see we've got some fill in the blank style notes. And then scrolling down a little bit further, we've got part 1, identifying parts of an algebraic expression, and they identify how many terms are there, the constants, the variables, and the coefficient. We have example 1, example 2, partner practice, and then independent practice. And then you would display that using these slides here. So the slides, a lot of them, if you're familiar with anything that I've created in the past, they're going to be like clickable like this. And so if you're a teacher or a student working on it by themselves, they can fill in the blanks to determine what these vocabulary words mean. And then similarly, here is example 1, kind of worked out. So how many terms are there? Well, what is a term? Whatever is separated by plus and minus. So we've got 7b, 5n, and also 6b. We have 4 separate terms. What's a number on their own? Okay, that'll be the 5. That's the constant. You can see I'm just kind of like breaking things down. We have our variables, and our coefficients is the number in front of the variables, which is 6, 7, n. You can even see the 1 populates in front of the n there. So that takes us here. And then similarly, a lot of the slides will have a Polypad. This is the part that's going to be supportive of our ELL learners. So our English language learners, they oftentimes will do well if we give them visuals. So here we can see 3x plus 10 plus 4 plus 5y. And if they try to snap the y and the x together, they just don't snap together. You can put them on top of each other, but they don't snap in the same way that the 10 and the 4 will snap together. So 3x plus 10 plus 4y has 3x plus 14 plus 5y. So you can see that is that. And then these are, you can't edit them, but you could make your own. We'll talk more about that as this video progresses. So I'm not going to go through every single example, but this is how you would use algebra tiles to model these. I couldn't model these because I mistakenly used W and B, and it'll only do X and Y. So this one doesn't have algebra tiles, but once we get to, we have some note taking on the next page about combined like terms and distributive property, which are 2 skills. And what is expected is right here. So kids would write that text down and then follow this example of why it works. And so a teacher would really bring that to life. So here's the first one with algebra tiles. It says simplify each expression by combining like terms. So students are now on this example, 3x plus 2x plus 10 plus 5. Again, you would click on the link and really show them why 3x plus 2x. These can go together to make 5x. So you can't really group them, but that's 5x. And then these you can merge to make 3x and 15. And if you try to put the 15 on the x's, it doesn't snap together. So that's how we get that as the combined like terms. So that's part 1. Part 1 is simplifying each expression by combining like terms. You can see example, example, partner, partner, and then the links to Polypad are only on the slides. And I also, animated a few of them. But again, the links are only on the slides for the Polypad part. Moving on to part 2. Part 2 is going to be about distributive property. So this is how you model distributive property using algebra tiles. Let me try to click on that link. Okay, I'm going to need to get out of slideshow mode here. I'll do this one. It says 2 times 10x minus 4. And so you can see I click on it and it opens up the model. And first off, you can see here's our 10x minus 4, and we wrote it twice. It's literally y. It's literally 10x minus 4 2 separate times. And then again, these can snap together, and here we can see 20 x's. And that's it. That's how these algebra tiles can be helpful. We just count up our x's and we try to snap together our coefficients, our constant values to create 20x minus 8. All right, so here you can see we got the same thing, partner practice, independent practice, and then I did part 4, which is going to do multiple things at once. So in part 4, what we're going to see is distributive property and then combined like terms. So to see what that looks like, All right, I would ask my class, all right, well, what is inside the parentheses? 2x plus 1. It looks actually like this one. I'm glad I'm looking at this one because it looks like I forgot the plus ones. So I'm going to add those now. And you're also going to get a little peek behind the curtain on how you make these a little bit. So I would just go to numbers and number cards. And I like the number cards instead of the number in the algebra tiles because these snap together. So you can see I've got 2x plus 1, and I've got that 5 separate times. And that's why I have, let me save that. So again, I can snap all my constants together. And then these don't snap together, I just count them up. So we have 10x plus 20. Same procedure here, and again, there's the Polypad. Moving on to the last part, which is part 5. In part 5, what I have is combining like terms and then evaluating for a given variable. I wanted to show how you can model that using algebra tiles. So we have 7x plus 3x plus 5. So again, you'll see that I wrote the 3x plus 5 3 different times. Here it is once, twice, 3 times. Again, we'll snap all these like terms together. So in simplest form, we have 7x and 3x, so that's 10x right there. And of course, these are draggable, so we have 10x plus 15. But if x equals 5, then you can see that I took my x's and I changed them all to 5s. Here's 7 green 5s. Here's 7 green x's, and here's 7 green 5s. Here's 3 orange x's, which are these 3 orange x's, and they're 5s. And then we have our 15, which is, just for simplicity, I'll change those to blue. And then, of course, we would simplify using order of operations. We end up with, 10x plus 5, or 10x plus 15. 10 times 5 is 50, plus 15 is 65. And if we just, merge it all together, we end up with 65 right there. So the purpose, again, just to reiterate, is to give students a visual on why these are what they are. Try to give practice and partner practice for each question. Super open to feedback. If anybody wants to discuss how to teach with algebra tiles, if anybody would like me to create more models, I'm happy to do that also. I can model this in your classroom, etc. But I just think that algebra tiles are helpful just for making the content come to life and make it a little bit more easy for students to make sense of it. So just to model through one more, this is one of the independent practice ones. It says 7 times x plus 2 minus 3x. So the first thing I would do is ask students to distributive property, and a kid who didn't understand why distributive property means that there's 7 of them, that's this part right here. We have x plus 2, and we have it 7 separate times. 1, 2, 3, 4, 5, 6, 7, and then here's the minus 3x. So I would then start combining all my like terms. Well, I know that all these 2's are constants, so if I just hold down shift and I click on all these, then they can all be grouped. Okay, my 2's equal to 14. And then what you'll see is that the x's do snap when they're inverse. Those become zeros. So I'm left with 4x right there, these 4 x's. And then I'm also left with 14, so it's 4x plus 14. Well, if x was equal to 1, then each one of those x's would be one of these oranges, and then these would be, this minus 3x would be minus 3, but they're all they're 1s, so multiplied, and we'd merge those together to get a simple value of whatever it equals, 18. So yeah, this is kind of how you would use these algebra tiles. So just a quick video. Please reach out if you have any questions or comments or anything that I can do to make this easier to use or anything like that. All right, thanks a lot. Appreciate you. Thanks for all you do. Bye.